There is a building material you can cut with a handsaw, like wood, except it is concrete. Drop a block in a bucket of water, it floats. It weighs 1/6 of a standard concrete block. A wall section built from it survives 2000 degrees for 4 hours without structural failure. It insulates 6 times better than conventional concrete, meaning your heating bill drops and stays dropped for the life of the building. It has been manufactured commercially since 1929. It is in active use across dozens of countries on every inhabited continent. In the United States, there are 2 factories that produce it. 2 every hurricane season, every wildfire outbreak, every tornado corridor, tens of billions of dollars in residential losses, hundreds of thousands of homes. Year after year, the same building material catches fire, splinters apart, gets lifted off its foundation and scattered across the next county. And a material that survives all of it has existed for a century. Most American homeowners have never heard its name. It is not banned. It is not unproven. It is not prohibitively expensive. So why don't you have it? There are documented cases, post-storm aerial surveys, engineering reports filed with municipalities, where a single structure built with this material stands intact, while the lots on either side show nothing but bare slabs. The debris line stops at one wall. The roof is undamaged. The neighbors are gone. That image exists. And the question the image demands is not why the material survived. The question's, who decided you were never going to build with it? If you believe safer homes shouldn't be a secret, subscribe and help us keep digging. The first thing most people assume when they hear this story is that the material must be experimental, unproven, something being developed in a university lab that hasn't cleared regulatory hurdles yet. That assumption is wrong in every particular. Autoclaved aerated concrete, AAC, is fully approved for use under the International Building Code in seismic design categories A, B, and C. It has been reviewed and tested by American standards bodies. In the 1990s, 2 commercial factories opened on American soil to manufacture it, one in Georgia, one in Florida. Both operated, both produced blocks, both eventually closed or were absorbed. The material did not fail the market. The market was arranged so the material could not reach it. Those are different things, and the difference is the story. To understand why, you have to go back to Stockholm in 1924, to a researcher named Johan Axel Eriksson, working at the KTH Royal Institute of Technology. His specialty was thermal insulation in building materials, how to make structures that held heat in winter without requiring enormous walls of dense stone or brick. He was experimenting with combinations of lime, aluminum powder, and water. What he was looking for was a lighter mix that cured reliably. What he got, almost accidentally, was something else entirely. When the mixture was exposed to high temperature and pressure inside an autoclave, a sealed vessel designed to accelerate the curing process, a chemical reaction occurred that nobody had predicted at that scale. The aluminum powder reacted with the lime. Hydrogen gas formed. Millions of tiny bubbles were generated inside the mix and trapped there as the material hardened. The result was a block that was roughly 80% air, but air locked inside a rigid mineral structure. It floated in water because it was mostly air. It would not burn because there was nothing combustible inside it. And there was something else. The extreme heat and pressure of the autoclave caused the silica and calcium in the mix to fuse into a mineral called tobamorite, a calcium silicate hydrate that forms naturally inside certain volcanic rocks, the same rocks that have held ancient structures together for thousands of years. Eriksson had essentially replicated a geological process in an industrial vessel and turned it into a building block. He patented it in 1924. Commercial production began in 1929 at a factory in Ixhult, Sweden, under the brand name Ytong, a combination of Ixhult and the Swedish word for concrete. Ytong became the first registered brand name for a building material in the world. By 1943, the technology had spread to Germany under the Hebel brand. By the late 20th century, it was being manufactured in more than 40 countries. In parts of Europe, AAC accounts for a substantial share of all new residential construction. In the Gulf states, in India, in East Asia, the material is standard. Here is where it gets strange. Because when you look at the physical properties, the case for AAC in the United States is not marginal. It is overwhelming. A standard wood frame house reaches structural failure in a house fire in minutes. An AAC wall survives the same fire for hours. In a hurricane, wood frame structures fail at wind speeds that AAC walls are engineered to withstand. In an earthquake, the material's light weight means the seismic forces acting on the structure are dramatically reduced. In a flood, AAC does not rot, does not harbor mold, does not swell and separate. In extreme cold, its thermal resistance means heating systems work a fraction as hard. And this is the part nobody mentions. There is a genuine limitation to AAC, and a credible script owes it to you. The material must be protected from prolonged direct water exposure. Uncoated, unrendered AAC will absorb moisture over time, and that moisture can degrade its structural performance. In Germany and Spain, exterior render or a specialized mortar coat is standard practice. Every trained builder knows it automatically. But when AAC arrived in the American market in the 1990s, many contractors installed it the way they would install any other masonry product, without the required protective finish. Blocks underperformed. A few projects had problems. The reputation of the material suffered. But the material had not failed. The installation had failed. In a market where only 2 factories existed and no training infrastructure had been built, that distinction was never corrected. The story became a seasoned work here, which was a story that served certain interests very well. Those interests have a name. The American Wood Council is the lobbying and code advocacy arm of the softwood lumber and engineered wood products industry. It maintains a substantial operation dedicated full-time to shaping the language of the International Building Code, the model code that most American jurisdictions adopt, and that determines which materials get an easy approved pathway and which materials require something much harder. After 2019, lumber demand in the United States surged to levels not seen in decades. The industry the AWC represents had every reason to ensure that the building code remained exactly as it was, structured around wood, written for wood, familiar to every bank, insurer, and appraiser in the country, because wood was all any of them had ever evaluated. The International Code Council has had AAC in its technical committees since the 1990s. 3 decades, no full residential standard pathway has ever been completed. Every AAC project in the United States still requires, in most jurisdictions, individual approval from the local building official, case by case, project by project, each one requiring custom engineering, documentation, and an approval process that can add months and tens of thousands of dollars to a build. Against that apparatus stands the Autoclaved Aerated Concrete Products Association, which has pushed for full code integration since 1998. Its resources are not comparable to the AWC's. They are not in the same category. This is not a conspiracy. There are no secret meetings. There are no fabricated documents. What there is incentive. The system is not broken. It is working exactly as designed. Every subscriber makes it harder to bury this. Stay with us. The consequences land on real people. A family on the Gulf Coast rebuilds after a hurricane using standard wood frame construction. The only type their bank will finance. The only type their insurer will rate at a standard premium, and rebuilds again 5 years later when the next storm comes through. A homeowner in rural New Mexico hears about AAC, contacts a local contractor, specifies the material for their build, and is told that no local appraiser has comparable sales, meaning the finished home may not appraise at its actual value. The mortgage falls through. They build in wood. The house that survives the disaster still faces its own set of problems. The appraiser has no comparable sales. The insurer has no actuarial model for a structure this durable. The mortgage officer flags it as unusual construction. The house is standing. The paperwork punishes it anyway. It needs no replacing. That is exactly the problem. But here is what the blueprint actually looks like right now. AAC is buildable today in a significant number of American jurisdictions. The pathway requires more work than a standard wood frame permit, but it exists. Several states across the South and Southwest have completed AAC residential projects, structures that are standing, occupied, and permitted. The place to start is your county's building department. Ask directly whether they have a pathway for AAC under alternative materials provisions of the IBC. Ask your architect to specify it for the structural envelope and to prepare the fire and thermal documentation for the permit file in advance. The ACPA, the Autoclaved Aerated Concrete Products Association, maintains a current list of approved suppliers and contractors with experience in correct installation. If you want the detailed breakdown, the ICC voting timeline, the state-by-state legal status, the cost comparison with wood frame construction over a 30-year horizon, drop the word 1924 in the comments. That is the year the patent was filed. That is how long this has been sitting there. Here is the reframe. The block still floats. A handsaw still cuts it like soft wood. The patent is still dated 1924. None of that has changed. What changed over 100 years was the infrastructure built around a different material. The codes, the financing, the insurance actuarial tables, the appraiser training manuals, the contractor education, the building department familiarity. That infrastructure was built piece by piece, decision by decision, committee by committee, with a great deal of organized effort by people who had a financial interest in the outcome. The material was not missed. The technology did not slip through the cracks of a distracted industry. Every relevant institution has known about AAC for decades. Some of them have sat on committees that reviewed it. Some of them have voted repeatedly on how it should be classified. If this channel exists to do one thing, it is to document the gap between what works and what you are allowed to easily build, and to ask who benefits from keeping that gap open. Subscribe if that question matters to you. They didn't miss it for 100 years. They chose to miss it.